All right, here we go. 7.4. Solving systems by, all right, so we've talked of the solving systems by graphing. We just did solving systems by substitution. Therefore, next is solving systems by, anybody have it? Elimination. Elimination. Also called the addition method. I think elimination is more popular. The elimination method. So you don't have this in your notes. I just want to quickly review and again, what are we talking about when we're talking about solving a system? Two or more equations where the solution is the point of intersection. Here was our opening example of solving by graphing. We graphed the two lines. We found the point of intersection to be the point 2, and therefore then the x value is 2 and the y value is 2 for this system of equations, and we solved by graphing. Then we went on to solving by substitution. In that methodology, we had to first figure out what's the best way to start. We had to solve one of the equations for one of the variables. Top one for x, top one for y, bottom one for x, bottom one for y. And then we solved by substitution. That was the second methodology. And remember, in both situations, what were we after? The point of intersection. One graphically, visually, and the second algebraically, using math. The elimination method is also an algebraic method, using math. So that's what we want to do here. All right? So let's go ahead and here's the procedure. When you're using the elimination method, it starts out differently than substitution. Okay. So instead of choosing black X, black Y, blue X, blue Y, we have to choose either the X's or the Y's. The X's or the Y's. So instead of have 4 possibilities, we have 2. Either the X's or the Y's. Either the independent variables or the dependent. Now, most of the time we're going to use X and Y. It could be different variables. But again, that's the idea. So, what's your first objective? Get one of the variables. And what I mean by one of the variables, I mean either the X's or the Y's to add out. By adding them out, voila, they are gone. Whoosh. We eliminate them. Hence the elimination method. We eliminate one of the variables by getting them to add out. They're gone. And once they're gone, what's left is solvable. And we'll show you how to finish up. All right, so how do you determine which one to choose? Look at the coefficients of the variables. Look at the coefficients of the variables. Remember, coefficients are the multipliers. To make a wise choice of which variable to eliminate. You get to choose who to eliminate. I know that's exciting. All right, so you choose. You make that choice. All right. How in the world do these variables get eliminated? Well, here's how. Work to get the coefficients, the multipliers of the variable, of one of the variables, and again, here's what I mean. I mean either the X's or the Y's, to be equal and opposite. For example, if you had 5x and a negative 5x, when you add them up, what do you get? 0. If you had negative 3y and a positive 3y, when you add them up, you get 0. And they're gone. Whoosh. They're eliminated. And hence the elimination method. So again, you're doing this to get them to add out. That's how they get eliminated, by getting them to add out. So let's practice first determining what to get rid of, x or y. So again, let me back up a second and remember in higher level math, you always must start with what do I have? So 3 years from now, you're taking the SAT to get into college, and you see a system of equations. Your first thought should be, oh, this is a system of equations. Your next thought should be, oh, I can solve it by graphing, by substitution, by elimination, or by matrices when we learn that. You look at it and you say, you know what, this one, and I'm looking right here right now, graphing is the least efficient. So usually we want to go mathematical. Substitution, elimination, matrices. Is this an easy one to solve with substitution? No. No. Because you'll end up with fractions and it's a pain. You always think substitution first because it is I think the easiest method. But if you're not going to use substitution, then you say, okay, I guess I'm using elimination. Now your next thought must be, because I'm using elimination, do I want to eliminate the x's or do I want to eliminate the y's? And that's where you're at right now. Okay? So that's our choice. So you're looking at the coefficients of the x's the x's are in red, and I'm looking at my y's in green. And if I had to eliminate either the x's or the y's, what would you choose to eliminate? Don't say anything yet. So on 3, tell me x's or y's. All right, here we go. 1, 2, 3.
Y's.
It's going to say something goofy, but all right. So the y's. The y's. And here in green, how? Just add the equations. Just add the equations. Our y's are all set to add, aren't they? Positive 2y and negative 2y equals?
0.
Whoosh, y's are gone, eliminated. Goodbye, y. Nice knowing you. All right, easy choice on that one. Very easy. Piece of cake choice. Questions on that? That was a nice one. That was obvious. Okay, second example. Now we've got 4x and 2x, and a negative 7y and a negative 5y. One of them is definitely easier than the other. So again, I'll give you a second, and then I want you to tell me x's or y's. On 3, 1, 2, 3. X's are by far the easiest here. X's are the easiest. Are they already ready to roll?
No.
No. But we can make it ready. Is it easy to make a 4x into a negative 2x? Is that easy? It's not. Can you make a 2x into a negative 4x? By doing what to it?
Coefficient.
Let's think multiplication. What can I multiply a 2x by to get it to be a negative 4x?
2.
So how would you do this one? You would multiply the bottom equation. Multiply the bottom equation by, what did we say, class? Negative 2. You would multiply this bottom equation by negative 2. You notice I put a bracket around the whole bottom equation and a negative 2 out in front. Wouldn't that get me to a negative 4x? And then when I add a positive 4x and a negative 4x, what do I get? 0. Whoosh. They're gone. Eliminated. Sayonara. Hasta luego. Ciao, baby. All right? They're gone. And that's what we're after. And by the way, multiplying an equation by a -2 is the same concept as unreducing. It's the same concept as unreducing. Because all I'm doing is just changing the form of it. I'm not changing the value as long as I multiply the whole equation by -2. I'll show you that in a minute. We'll get there. Let's do the next example. Okay, third example. Again, you got to make a choice. X's. Question.
So if they asked you to do it, what would the solution look like?
Wait for the solution, all right? We're just figuring out the first step. So hang in there. That one I don't care. All right, so third example. Do you want to get rid, again, everybody's got to be thinking now. Do you want to get rid of the X's or the Y's? 1, 2, 3.
Y's.
Again, you're looking at the X's. You have a 4X and a 7X. They don't match too good. Positive 5Y and positive 5Y. They're really close to getting equal and opposite. You want to get rid of the Y's. Somebody tell me how. Anybody tell me how? Andrew?
Multiply the one equation by negative.
Yeah, multiply either top or bottom. I'm going to go top. Multiply top by -1. So our choice was the Y's. And to get the Y's to be equal and opposite, I'll multiply the top by a -1. Won't that give me -5Y on the top and positive 5Y on the bottom? And then they'll add out. Whoosh, eliminated. Sayonara. They would. Oh no. D. A's and B's. I'm totally confused now. I'm stuck. Don't know what to do. No, hey, what are you going to eliminate? The A's or the B's? All right? So looking at this one, A's or B's, none of them's all that easy, is it? But what would be easier? Getting rid of the A's or getting rid of the B's? What would you say? The A's are easier. Anybody got a sense on how to get rid of the A's? If you do, raise your hand. Look, what we've been doing is analogous to fractions. So watch, don't write this. So for example, earlier example, we may have had something like this, right? And to get a common denominator, we would have done that to one of them. This example is more analogous to this. And wouldn't I then do this here and that there, right? Does that help anybody to know how to do it? Alexandra?
Multiply both equations by a common denominator.
Okay. So, Andrew, tell me what to do. Let's multiply the top by... Let's multiply the top by 2, and let's multiply the bottom by, Andrew?
3.
Exactly. Right? Because we're going to get them both to 6, as Alexandra said, that quote-unquote analogous common denominator, right? So again, we chose to get rid of the A's, and to do that, we can multiply the top by 2. Won't that give me a 6A? And the bottom by 3, won't that give me a -6A? Ah, equal and opposite. Sayonara, baby. Ciao. Hasta la vista. Right, they're gone. So this is how you start solving by elimination. So now let's do the full method. So here we've got a black equation, -4x minus y equals -35. A blue, 3x plus 2y equals 30. Now, if you just had this problem all by itself, you might decide to solve it by substitution. But we're trying to learn the elimination method, and this is a little easier one, and so we'll do it elimination, okay? And by the way, if the book says solve them by elimination, you got to solve by elimination. Okay. So again, our choice is get rid of the x's or get rid of the y's. And you will want to get rid of the y's. Now, some of you aren't saying anything. Hopefully you're not saying anything because you don't like to participate. Very silly. Not smart. Hopefully you're not saying anything because you don't know what to do. Because I assume if you don't know what to do, you're going to raise your hand and ask a question, and I'll explain it a little bit more in depth and try to get you to understand. And I know you're smart enough to ask a question, I would hope. All right, we're going to get rid of the y's. So I look at my y's, and I say, what will it take to get either a negative 1 to be a positive 2, or a positive 2 to be a negative 1? So Andrew's been giving all the answers here late, so somebody else tell me what to do to this one to eliminate the y's. Josh? Multiply the top by 2 is exactly right. So I'm going to take a green bracket, I'm going to put it around the top, and I'm going to put 2 out to the left. We are going to get a new equation. Now we have to distribute. 2 times negative 4x is a negative 8x. 2 times a negative y is a negative 2y. Now look, here's the common mistake. You have to multiply it times the whole equation, otherwise you're changing the value. 2 times a negative 35 is a negative 70. You had to do it to the whole equation. Some students forget to do it to the number on the right of the equal sign. Don't make that mistake. Okay, that's how we start. Next step, add the equations. So next step is add the equations. I boxed them in to be clear. The black became the green one, right? Now we have the blue and the green. And you're just adding up the columns. Positive 3x and a negative 8x is a negative 5x. We won't put this in here, but positive 2x and negative 2x is 0. Normally I don't bother with the zeros, but I'm putting it there for emphasis, right? That's what we were after. We just eliminated the y's. They're gone. And good. And the right side, we get a negative 40. Okay. So we've accomplished our goal to eliminate one of the variables. Where do we go from here? What would be the next step? Kaylin? All right, good. So Kaylin says the next step is solve for the variable. Right? Solve the equation now for the variable. And she said we're ready to divide both sides by negative 5, right? And we end up with x equal 8. Not a big deal, right? It was a pretty easy equation. X equal 8. Okay, hey, didn't we just find the x coordinate of the point of intersection? Cha-ching. How are we going to get y? How are we going to get y? You could do the same thing, but that's too long. It's the easier way. How do we get to y? Adam? Awesome. Look at that. Yeah. So now to find the other equation, or I'm sorry, to find the other variable, use substitution. To find the other variable, use substitution. Hey, do we sub it into the black, the blue, or the green? You could use any one. I'm looking at the easiest one to solve for y. You know what? It's probably a toss-up between the black or the blue. The green usually has bigger numbers. The one you made usually has bigger numbers. So you're usually going back to one of the two originals. What do you guys want to use, black or blue?
Black.
Black? Blue? I'm going to use black. You can use blue if you want. So where the x is, I'm putting my parentheses, right? And we're subbing in our 8. So I brought my black down, -4. Again, you guys have to understand, if you keep looking at your screen to what to write, you're not understanding. Look at the black on your paper, bring it down, and where the X is, put the parentheses to put in the 8. That's what you're doing. You're not copying numbers. Otherwise, you don't know what in the world you're doing. You're looking at the black one. You're reproducing it with the parentheses where the X is and putting the 8 in where the X is. Okay. So now we got to add a positive 32 to both sides, right? Shortcut would be add a positive 32 to that side. We get -y equals -3. Class, if -y equals -3, y must equal, and our final answer is 8,3. This was consistent and independent. That's the point of intersection, 8,3. Consistent and independent, point of intersection, 8,3. That's the method, elimination. Let's do another. Okay, so again, I got to choose eliminate x's, eliminate y's. I think in this one, it's probably, it's about 6 of one, half dozen of the other, to be honest with you. Windows 10. So I got to stop promoting Windows 10. It's driving me crazy. All right, let's get rid of the x's. And for time's sake, hopefully you agree, multiply the bottom by -2, right? Bracket -2 on the bottom. Distribute -2x, -10y. Again, if you know what you're doing, you can do it. You don't have to look and copy numbers. You're doing it yourself. And hopefully -34, right? Don't forget to distribute all the way through. Be careful if you don't want to rewrite the black equation underneath the green one and you just want to add them up with the blue one in the middle that you're not going to use. It's a little risky. Some of you, you're careful, you write neatly, you can do it. When I used to have an overhead, I would lay a pencil over that middle equation and you wouldn't see it, and therefore it's clear what to add. Again, you're ready to add them now. But for some of you, it would be smart to take 2 seconds and rewrite it so that these are together to add up. Now, I only did that because I didn't want to get confused, that's all. Right? I just rewrote the black so I wouldn't get confused. Again, if you're careful, you don't need to rewrite. -2x and +2x, 0. Ah, good. I eliminated the x's just like I planned. -10 and a -1 is a -11y. And 34 negatives and 10 more negatives are 44 negatives. It wouldn't be so bad, but I thought I got rid of it. -44. Next, we're going to solve for y, which is easy. Divide by a -11, right? Doing the shortcut. And we end up with y equals 4. Next step, substitution. You want to go black or blue?
Black. Blue. Blue.
Blue already just has X. I'm going blue. I'm going blue. It's either one's not bad, to be honest with you. And there's no wrong answer. Just one maybe is a little easier. Because now when I stick that 4 in, all I got to do is move the +20 by doing what to the other side? -20, right? Again, you're adding a -20 to both sides. And I get x equals -30. That would have been a fun one to graph, wouldn't it have been? You needed to go negative 30. You'd have to turn your paper sideways. Okay, that would have been a pain. Final answer, negative 34. Consistent and independent. Doable, right? It's not hard. Whoa, 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 whoa. Earth to Kool-Aid people. My soul, you Kool-Aid people. I did the front part of the blue and the number of the black, huh? Oh, brother. All right, this is what, a positive 17. Good night. Right? I used the black. Don't do that, right? Don't write your problem wrong. You'll get it wrong. All right. 17 and negative 20 is a negative 3. Final answer, negative 3, 4. You all drinking Kool-Aid out there? Come on, I'm telling you, you got to be thinking while we're doing these. You just can't. If you're just copying what I'm doing, all right, I got to do it again. You're an idiot, all right? You're an idiot. If you are just copying what I'm doing, you're an idiot. You have to be thinking through. You have to do what I'm doing, not copying what I'm doing. You have to do what I'm doing. And when you went to copy the blue, you should have caught that it was a 17, not a negative 10. Because if you're copying numbers, you're an
idiot.
Thank you. All right, good. No, you're not going to learn that way. You have to be thinking. All right. So negative 3, 4. All right, last one. This is one you definitely need to do by elimination because you get nasty, nasty, nasty fractions the other way. There's not a clear choice, X's or Y's, is there? You know, this one's 6 of one, half dozen of the other. And both ways, you got to multiply one by a positive and one by a negative. I usually choose the one that gives me the smaller numbers. So I'm either going to use 5 and 6 or 4 and 5. So I'm just going to go for the Y's. So somebody tell me what to multiply the top one by. Okay, if I go the top by 5, what does that make my top Y's? Negative 20. How do I get my bottom Y's to be positive 20? Right? I got to do a negative 4 on the bottom. Do you agree? Okay. On these, let's just use our color because we need new black and new blue. Say, Mom, made us black and blue in there today. All right. 5 times 5x, 25x. 5 times negative 4y, negative 20y. And 5 times a negative 23 is a negative 115. New blue. 4 times negative 6 is a negative 24x. I'm sorry, negative 4 times 6x is a negative 24x. Negative 4 times a negative 5y is a positive 20y. Ah, our y's are going to be eliminated. Negative 4 times negative 28 is positive 112. Positive 112. And you would use your calculator if you're worried about that. Everybody okay with that? Our next step is to add them because that's when you do the eliminating, right? Oh, good. Look at that. 25x's minus 24 is x. And a negative 115 and a positive 12 is negative 3. Look, we don't have to do anything else on that step. X is a negative 3. We found the x coordinate of the y of the point of intersection. Cool. All right, you got to find y. I would go to original black or original blue. They have the smaller numbers. And you know what? Does it really matter which one? They're about the same. I'll use the black one, but they're pretty similar. So again, how do you get that last number? Substitution. Where my x is, I got to put in my negative 3. So we get negative 15 minus 4y equals negative 23. Add a positive 15 to both sides. Negative 4y equals negative 8. Divide both sides by negative 4. Y is dos, C. And our final answer, negative 3, 2. This thing was consistent and independent. All right, you got it? Hey, if you need it, the video's up on the internet. You can fast forward to the parts that you need. But work on getting it tonight, because tonight's the time to get it figured out. Those you guys going to the ball game, you know what, if I were you, if I had homework at 3:05, I'd come to either my room or Mr. Satterfield's room and work on homework till it's time to leave. That's what I would do if I were you. Now, if you're leaving right away, you know, I can't help you. I'd try to get my homework done. Maybe you get a break in a class today, but be careful.